Hello everyone and welcome back to my channel. Well, as you know, I have started a series for Further Maths, and in that we have already started Surds, and we have done the basics of Surds as well as how to simplify them. So in today's class we'll be doing the rationalization, which I think most important topic in Surds. Like the harder questions you will see are based on rationalization. So let me start with the rationalization, the basic definition. What is rationalization? It's basically the process of removing surds from the denominator of a fraction. Say for example, 1 over root 2. So root 2 is a surd number and that is in your denominator. So if you want to make it in a standard form, or like the actual way of writing it in a surds, we don't write surd number in denominator, we always rationalize it. And so that surd number is not accepted, we have to remove that, and this process is called rationalization. So there are two ways by which we can rationalize. It all depends on the type of question. Your first question is 1 over root 2. So when there is only one surd number in the denominator, we just divide and multiply with the same root number or same surd number. See, in mathematics, we cannot add or subtract anything from our own. I can't just multiply it with root 2. If I'm multiplying, I have to divide it to make a balance, because root 2 and root 2 will get cancelled out. So ultimately, you haven't made any sort of change in the question. But doing so, we are actually removing the surd number from denominator. Now if I multiply 1 times root 2, it will give me root 2. And root 2 times root 2 will give me 2. And in this ways, though the meaning, the value is still the same, still if you simplify root 2 over 2, it will be root 2 over 2 can be written as root 2 times root 2. It's still 1 over root 2. Only the form is changed. You have studied the physics. Energy can neither be created nor be destroyed. It can only change its form. So it's a kind of that thing. Values is still the same. Only the form has been changed. And why? Because the surd number is not acceptable in denominator. Well, let me do one more question on the same pattern. It's 2 over root 3. Again, there is just a single surd number in denominator. So multiplying and dividing with the same root 3, answer will be 2 root 3 over 3. So that's how you can rationalize it. The second type of rationalization is, which is a binomial denominator. That means it's a little bit advanced one, where the denominator is a binomial involving a surd. That means both terms can be surd, both terms can be like one can be surd, one can be a number, but there has to be one surd number in denominator. Take an example, 1 over root 2 plus 1. You can clearly see in denominator there is a surd number, but now there is an integer. There's another term which is not a surd number. It can be, it cannot be. So in that case, don't do divide and multiply with the same number. If you will do, you will not be able to remove the surd number from the denominator. Let me show you how. Because 1 times root 2 plus 1 will give me root 2 plus 1. And root 2 plus 1 times root 2 plus 1. These are the two brackets. And it will give me root 2 times root 2 is 2. Root 2 times 1 is root 2. 1 times root 2 is root 2. And 1 times 1 is 1. So this will give me root 2 plus 1 over 3 plus 2 root 2. And you can clearly see you are still not able to do so. And if you think you'll multiply it with again, so doesn't matter. If you keep on doing so, you will keep on getting a denominator, a surd number in denominator. So instead, we have to divide and multiply with such a number that can easily remove the denominator, and that would be root 2 minus 1. What I did, I have just changed the sign. So this will be root 2 minus 1. Keep that in mind, because there was a positive in the denominator, root 2 plus 1. There was a plus sign, a positive sign. This is the reason I have divided and multiplied with a negative sign. So root 2 minus 1 over root 2 minus 1. If it would be a negative in denominator in the original question, you have to make the sign opposite and divide and multiply using the positive sign. So I'll show you that as well. Let me show you this one. So after dividing and multiplying with root 2 minus 1, now doing the same thing, let me multiply numerator. So 1 times root 2 minus 1 is root 2 minus 1, and root 2 plus 1 times root 2 minus 1, same, we have to expand the bracket. Or there is a direct way of solving this. There is a direct identity. I can say a plus b times a minus b. That means two numbers, two terms that are same but separated by the different sign. In one bracket there is a plus sign, in another bracket there is a minus sign. Directly the answer would be a squared minus b squared. This will save your time because you're doing a times a, then a times minus b, the basic way, the conventional way of solving the brackets, expanding the bracket. We can just skip that and directly write a squared minus b squared. So a squared, that means root 2 whole squared minus 1 squared. Root 2 minus 1 over 2 minus 1 is just 1. So answer is root 2 minus 1, and you can clearly see we have removed the surd number from the denominator. Let's say now instead of 1 over root 2 plus 1, we have 1 over root 2 minus 1. So I'll divide and multiply using positive sign, the opposite sign. So it will be times root 2 plus 1 over root 2 plus 1. So 1 times root 2 plus 1 is root 2 plus 1 over root 2 minus 1 times root 2 plus 1. Again same, a plus b times a minus b will give me a squared minus b squared. Root 2 whole squared minus 1. So answer is root 2 plus 1 over 2 minus 1 will give me just 1. Let me do one more question. Say for example, we have both the terms being a surd number. That means 2 over root 2 plus root 3. Previously we have seen that we have the two terms, but one was integer, one was a surd number, but now both the terms are the surd number. In that case, still we'll be doing the same thing. That means we have to divide and multiply using opposite sign. So it would be root 2 minus root 3 over root 2 minus root 3. Same, 2 times multiplying the numerator. So 2 times root 2 minus root 3 over root 2 plus 1 root 3 times root 2 minus root 3, same, a plus b times a minus b. That means root 2 whole squared minus root 3 whole squared. So it would be, if I'll expand this bracket, 2 times root 2 minus 2 times root 3 over 2 minus 3, that is minus 1. So I can write minus 2 root 2 minus 2 root 3 or 2 root 2 plus 2 root 3. If you feel like it's what I did, you can just go back and see the video again. It's a simple one because you're doing further maths, so I assume that these things are pretty easy for you. It's pretty understandable. Now suppose there are the binomial terms. That means there are two terms in the numerator as well. Suppose it would be 2 plus root 3 over 3 plus root 2. So same, we have to divide and multiply using opposite sign. That means 3 minus root 2 over 3 minus root 2. Because it's a multiplication, so I have to multiply numerator and numerator, multiply denominator and denominator. So this will be 2 plus root 3 times 3 minus root 2 over 3 plus root 2 times 3 minus root 2. So 2 times 3 will give me 6 minus 3 times minus root 2 will give me negative root 6. Then root 3 times 3 will give me 3 root 3. And root 3 times root 2 will give me negative root 6. Over a plus b minus a plus b times a minus b, a squared minus b squared. So this will give me 6 plus 3 root 3 minus 2 root 6 over 9 minus 2, which is 7. So this video was all about to describe you, to clear you the basic theory of Surds. We have completed all the theories. In the next class, we'll be doing the worksheets where we'll be doing simple to very hard questions. Also, if you want to enroll yourself for the GCSE classes, they are just £6 per hour, whether it's for further maths, for simple maths, or for any subject. It's just £6 per hour. And also you can book your first free trial. All you need to do is just email us at exactacademy@gmail.com. And if you want to access the free worksheets that are available at website www.exactacademy.com. So that's it for today. Bye everyone. Take care.